A couple things about it. If you use Postgres, Vertica is really nice because it's kind of based on Postgres in a lot of ways, which is not surprising because Stonebreaker, the professor who's kind of the father of Postgres, wrote the C-Store paper that became Vertica. So you can use your ETL via the copy command. If you're familiar with the copy command, you can just use the copy command as if you were loading data into Postgres. It works just great going into Vertica. Primary keys, they do have them in Vertica, but they're only for constraint validation. You know, if you want to make sure that you don't have duplicate data in there, that's the only purpose for it. By the way, it is free for up to 3 nodes and 1 terabyte of data. If you're a small startup and you're getting going, can't beat this deal. It's really good. It works. It's not limited at all except for the node number and the terabytes of data. At Etsy, we run a 40-node cluster. And each of those have, I think, a terabyte of memory and a whole bunch of storage, and it works real well. The other one I'll talk about is Google BigQuery. And so this is a Google Cloud product, and in order to compete with everybody else who's into this big data game, they came out with BigQuery, and it's really a pretty good system, but it's got some problems. When it first started a few years back, for example, it had actually kind of a weak SQL language. They've since improved that. The storage is inexpensive, but where they get you is in the pricing of how you do queries. So it computes that off of the CPU usage and also off of how many records, how many bytes of records are touched, okay? How many are read. Those queries can be very, very expensive, so be very careful. If you start playing around with Google BigQuery, you can rack up big charges very, very quickly. Interesting, until recently, the data ingestion was append only. You could only add records. You couldn't update or delete them. That's changed within about the past 6 months. You can now do it, but it's even pricier than doing an insert. I think it's roughly double the price. So if you're doing updates or deletes in BigQuery, it's going to get expensive. And there's actually no notion at all of indexes or primary keys in BigQuery. Let's talk a little bit about relational database indexes. Could be Postgres or MySQL. And you can see we have a table here, student ID, gender, and class. And so in the States, we have freshman, junior, freshman, sophomore, junior, and senior, and that's what those things mean. So what happens is the data gets written out to these small data pages. They're usually like 8K in size, right? And an index doesn't actually bring you to the data that you want. It brings you to the data page. So Postgres, for example, the index will point to the data page that record lives on. And Postgres will then read that entire file. Okay? And it does some caching with that too. But the data is kind of unordered. Any record could be on any one of these pages, but the index will get you to that really quickly. Let's see if I can do this here. Yeah, so this is like the index. You can see like record number 5 is on this page here, and number 10 is all the way up here. So it's not really ordered, but the index knows what page the record lives on. And so that's how it can be really, really fast. Now let's talk about a columnar database. The way this thing works, as I said, it's columnar. It stores the data as a column, okay? And so what it does is, in this case, we have the same table, gender, class, and student ID, but we've reversed the order. Remember how I said you want to go from lowest cardinality to highest cardinality? For gender, there's 2 genders there. And the way these databases work is they sort the data like this, okay? Oops, keep hitting that thing. Anyway, you'll see here that they're sorting first the female and then the male. Okay? And then it stores that data in what they call storage containers. So all the female gender are stored in this storage container, and all the male right here. And it knows that for female, there's 6 of these things right here. Okay? So very, very fast to get aggregate answers, like what's the count, okay? And then, you can jump this way. Once you get the female, then there's other data that's stored in this container also. And we'll see why that is so fast. Let's do an example query. So just like we had before, we have this table called students, and we've got a student ID, the gender, and the class that they're in. And let's say that we want to do this query. Select count from students where the gender is female, okay? So you know what these databases do is when they get a query like this, they have what's called a query planner, and it looks at the query predicate. That's everything after the where statement. And it looks like Postgres will look, gee, do I have an index that can do this for me? If it does, then it'll use it. If this query was select star from students where student ID equals 10, then it would know I can use the primary key and find that data really, really quickly. But for this one, we're just looking for wherever, the count where it's women. Okay? So let's see how each of these does this. So because we're not going by student ID, it's going by gender, it has to do a sequence scan. It has to read every single page. You can see this right here. It has to read every single page to get that count. Now you may ask, well, why don't we put an index on the gender field? If we had an index on gender, Postgres would probably not use it at all because the cardinality is very, very low. And Postgres thinks, wow, instead of going to this index and then going here and then going here, it's faster for me just to do a sequential read. Okay? And that takes a long time. Now let's talk about the Columnar Store. I showed you those storage containers where one of them is all the women students and the other is all the male students. And so to get the answer to the question, to the query, all it has to do is go here. And it already knows, oh, there's 6. And so the answer comes back almost instant. If you then were to put another correlation, well, show me all the females, the count of all the female students that are juniors. It only has to make 2 hops. First hop, and then it goes to the juniors. So this is the path. This is why this is very fast for doing an aggregation like count. I'm going to talk a little bit about the problem with problems with object relational mapping, ORMs. Does anybody use an ORM like Django here? Okay, so all those things are built to do updates and deletes. Okay, most of them have a store method where if you modify a record, you then call the store method, and that eventually filters down to an update or an insert statement. Okay, or a delete. And that's bad, as we will see in just a minute, because updates and deletes are like the most painful thing you can do to a columnar database. And I'm going to click back a couple things to show you why. Oops. Whoops. Okay. Storage container. Let's say that we update a record that lives here. What that analytic database has to do is it completely destroys this container and it rebuilds it from new. So that's a lot of churn. In Vertica, what happens is that if you update or delete a record, it's marked for deletion, and a process comes along later to manage that. Kind of like in Postgres, if you're familiar with vacuuming, it's very similar to that. So anytime you do an update or a delete, wow, you're doing a lot of on-disk reorganization. And that can slow down the system quite a bit. Good news. Even if you're using an ORM that does a lot of updates and deletes, we can still work around that to get really good results when we bring the data over to our analytics database. We'll talk a little bit about change history. When you have a table in a relational database where you're doing updates and deletes, you only get, after you update a record, you only get the latest version of that record in your table. The previous version has been deleted. Like, let's say someone is selling a piece of jewelry, a ring, and first it says it's made out of brass, and then they go and update it and say it's made out of gold. Well, now the record says gold in there for the type of material, and if you come along and look at it, you never know that it used to be brass. And a lot of analysts want to know about trends, like how come this product started selling? You've lost that information. So change history is maintaining all of the versions of a record. So for a piece of jewelry, if they've changed it 5 times, there'll be 5 records in there. Another good example is addresses. People change their address, but you want to know where they used to live before. You know, maybe for tax reasons, you got to figure out, gee, where were they when they sold this product? So the latest version is what we call a snapshot. Okay, that's like the latest version, and then a historical is a table that contains all the versions of all the records. So if you've got, you know, a listings table where there's a lot of churn, like Etsy's got like something like 100 million listings, and we want to know what's changed sometimes. Okay. So yeah, here's a real world example, you know, taking a listing from Etsy. When it first gets created, it's A. And then they make a change and it becomes A prime. And then they make another change and it's A double prime. Well, in your relational database where this stuff is stored, you're only going to have this in there. But we want all of this stuff in our analytics database. Okay? So we're going to talk about how to do that. So interesting thing, you know, the whole idea about update and delete happened for a couple reasons. One, you know, you want to be able to use a primary key to find something, and so you have to change it and update it because you can only have one value for a primary key. Otherwise, you're going to have duplication and all sorts of problems with that. And the other thing is cost. You know, storage in the 1970s was very expensive. Okay, and so you wanted to minimize your usage of disk storage because it was a business thing. It would save you money. But now, if you think about it, and analytics data didn't have any value then because there weren't the tools to do analytic processing. But over time, storage cost has come down. And because of the tools like Vertica and BigQuery, the value of the data has gone up. And we've done a crossover where the value of the data is now more important than the cost of the storage. You know, the storage is going towards 0, and the value of the data keeps improving. So how do we manage change history? I'm going to talk very briefly about these ways, but one of the ways, if you use an ORM, you can actually code into the ORM to like write out a log file for any change or put it in a table. You can also use triggers, like Postgres has great triggers, so that when something gets updated, you can put that the previous value, the old value, into its own table. Okay? You can have the table maintain its own change history, and then downstream in the data analytics stack, you can maintain the change history. So very quickly on these things. ORM logging, if you've got an ORM, you can code it, again, to here's your ORM, and it's interacting with the relational database, and any changes it's writing out as either a log file or it's putting it into a separate table. Okay? The downside with that is you have to have your developers design the change history tables, so they get involved a little bit. Another way is with triggers. You know, as I said, trigger comes in. Something like Postgres knows the old state and the new state, so it can just copy the old version to a new log table. Okay? So that works. Or you can maintain the change history within the table itself. This is a pretty cool thing. So this is an address table. And you can see that this user ID 2345, it exists twice. But we've got a field here called, we've got a field here called create date. So this address was on July 22nd, 2015. The previous address was back in 2011. So the current address is the latest one that's in the table, which is this one. Okay? If we wanted to answer the question, well, where did they live in 2012? Well, that's before 2015 and after 2011, so we know that this is where they lived. Okay? So this is maintaining change history of addresses within the table itself. And then you got change history in the analytics stack. And basically, what you do here is you just send all the data that you have as it occurs to your analytics stack. And what I mean by that is you don't propagate updates and deletes to your analytics stack. You just send everything there and put it in the table. And you may say, well, don't you run into a primary key problem? No, because there really isn't a primary key. These analytic databases don't really care. But a good question is, what do we do about the snapshot, which is the latest version? If we're just sending everything to the analytics stack, we've got everything in there. How do we figure out what the latest one is to create an efficient snapshot? Okay? Here's a common ETL pattern. You've got data in your relational database, then you extract the most recent data since the last run of the ETL process. Basically, your ETL software will ask the relational database, hey, give me all the records that have been added or updated since the last time I did this. Okay? And that's like on a cron job, so it keeps doing it every hour or whatever you set it. And then, often it goes to a staging table. So this is a staging table that has the same schema as the target table in the analytics database. Now, why do you put it in a staging table? Because if you're trying to propagate the updates and deletes, what happens is there's another little step here where you delete all the records from the target table that have the same ID that's in your current staging table. That purges those records out. Then, and only then, you insert the data from the staging table to the target table. Okay? And that's what your data warehouse is then. But all you're doing here is replicating what you've got in your production database so that it's just a snapshot every time. And we want to have historical data. And again, there's a lot of churn in your OLAP database when you start doing deletes. It's got to go and manage all those storage containers. Here's a better workflow. You just skip the target table stuff. The staging table altogether, and you just do your ETL. Hey, give me everything you got since the last time, and then you just insert it directly into the target table, bypassing the staging table. That avoids all that delete churn, and it's pretty easy to set that up. By the way, I'm going to talk just briefly about how Etsy does its current ETL. We used to have a process that would query our ORM to request the latest data, and that worked fine. But then we got into Kafka. Anybody using Kafka here? Okay, cool. And so what we did here, this is kind of fun. We have 1,000 MySQL servers that are our production servers. And those replicate to what we call the combo shards. Each one of these guys represents like 32 of those horizontal shards. And what we did was we wrote a bin log daemon that sits there, and anytime a change comes in from that replication, it gets a entry in the bin log. We read that, okay? And it's a very decipherable format. It's pretty good, easy programming to do that. So we've got this bin log thing, and then we publish this into Kafka as a topic. Every table has a topic. So that's flowing along. We have a 7-day Kafka window here. So in case we have some disaster down here, we got 7 days to recover. And then we have a Vertica Kafka subscriber. It sits there and it's listening for table messages to come along. Oops. And when they come along, it reads it, and then it puts that data directly into Vertica. No staging table, it just puts it right in. This is really nice. This is kind of set it and forget it. It just works. We found Kafka is very, very robust and reliable. If there's any problem on this end, because of the offsets that are here within the Kafka pipeline, we can just say, oh, pick up where you left off. So it knows to go to some offset number here, and it starts up and everything's fine and dandy. I think that a lot of ETL is going to happen this way in the future because more and more companies are starting to use Kafka. Let's talk about some data analyst use cases. So at least at Etsy, the data analysts, when they get into the office in the morning, they want to run queries, to do all their work, but they only care about the previous day and all the days before it. They don't care about today, because today isn't done yet. So they only care about the previous day. So what that means is that they can actually work off of a snapshot. At the tick over of UTC, okay, you can run a process which will create a snapshot, and then that's just a very simple table that they can query, and it's very, very efficient and fast. But these guys also want to do historical queries. We call these trends, right? Where is it? Yeah, there it is, trends. So this way we can say, hey, what's getting really hot tonight? Oh, gold jewelry is selling all of a sudden. But you can only do that, if you can look back at the history of jewelry and see what's happening with those things. So they want a snapshot, and they also want historical data. Well, we can provide them the best of both worlds, okay? The target table, if we're just sending everything into the target table, then that's the history. That's the history of all the versioning of the records in that table. And there's no update or delete, right? So all we're left with is the problem of how to generate an easy-to-access latest snapshot. And we're going to talk about that right now. Okay, so what's required on the analytics side is you have to have a timestamp field in every table that's called something like update date. Anytime in your production data, when you update something, this update date thing should be set to now. Okay, so we know when this happened. Because like in our example with the addresses, we had that same date field there, and we could tell that the latest date was their current address, right? So you have to have this for this to work. And so I'm going to provide two solutions on how to do this. One is a general solution, and it uses an analytics window function to select only the latest record. And then there's a Vertica solution that uses something proprietary to Vertica, which is it uses a special kind of projection. We'll talk about that in a second. Here's the general solution. Basically, what you do is you do a window function where you're selecting the row number and you're partitioning by whatever the unique ID is, like student ID or something. And you order by the update date descending. Okay? And then down here, and we call that RN. And then we wrap this thing here where RN equals 1. So we only get back the first row number that's returned. Okay? And because we're ordering it by update date descending, the first one with the row number 1, that's your latest one. Does that make sense? Cool. And then, often what you want to do, instead of putting this big honking query into all the queries that analysts are doing, I mean, this is terrible. You wouldn't want to write this in every single one of your queries. The better way is you can wrap it in a view like this, okay? Or you can, if you're just going to do a daily snapshot, you can just run this query and put it into its own table, and that's your snapshot for the day. And every day, at the tick over of UTC, you delete this table and run it all again. So you have that snapshot that way. It all depends what you want. If your analysts want to have to the minute or whatever data, then you want to wrap it in a view. If they're fine with a daily snapshot, then that's the better way to go. Vertica solution. Like I said, there's a type of projection called a top K projection. And what this does is you create this projection. A projection in Vertica terms, for those who don't know, is just a column stored on disk. Okay? And this is a special kind. So you create this projection and you select this stuff, and then you do a limit of 1, and you're partitioning by the ID, and again, you're ordering by update date descending. So that's the same that we just saw for the general solution. Then if we want to actually craft the query, we have to do something crazy like this, because the query planner is looking to see limit 1 over. When it sees this, it says, oh, there must be a top K projection, and so it'll find it and use it. But we don't want to put this in every one of our queries, so we'll wrap this in a view also. And then to get the snapshot, we just say select star from V listings latest, and that's the latest one. Whoops, sorry. Yeah, okay, so here's the advantages of this. So if this is your historical table, it's got all of your versions of the records like we've talked about. And Vertica automatically, when data is ingested, figures out, hey, is this record that came in, should that replace something in this top K projection? It's like a trigger. It's the closest thing that Vertica has to a trigger, because this happens at data ingestion, and it's pretty efficient, works pretty good. But you can see that the data for the snapshot in this top K projection is smaller than this because it's a subset. The difference in height here represents the versions that are not part of the snapshot. These are older versions, right? So again, this is efficient because Vertica only has to look at an incoming record once to determine if it should replace something in here. Okay, so now we're going to talk about some prizes here. I hope you guys have been paying attention. As I told you, I live in San Francisco, and born and raised there, and I like to sail. And I belong to this sailing club. I know it looks pretty bad, but it's a very, very famous club, sailing club, because we also have music, really good blues, rock and roll, and jazz is played there, and a lot of famous musicians have played there. So what I'm going to do here, so what I did was, let's see, I brought along some stuff, which you may like. I got some of these t-shirts, and I'll show it to you just so you know it's something decent. The material is actually quite nice on this. It's a t-shirt here that says Sausalito Cruising Club, and you notice that the anchor here has a guitar, because we're both sailing and music, right? This is a shirt that you will wear with pride. I've actually got 3 of these guys, and this one is, what size is this one? Okay, so these are unisex. It works both for men and women, but this one is size large. The other ones are extra large. So I'm going to start off this question here, and I only want women to try for this one, okay, because it's a smaller size. So the question is, which type of processing do big data analytics databases use? OLTP or OLAP? No, you can't. No, you can't answer. It's only for women right now. There'll be other questions. Do we have a woman in here who can answer this question? Yeah, go for it. What is it? Boom. Sold. That's great. Let me, yeah, why don't you come on up and get this? I'm sorry. I'm able to get these things out, but not back in. So there you go. Thanks a lot. Very well done. Okay, next question here. Columnar database does not use indexes. How is it optimized for speed? Anybody can answer this. Well, this guy back here. What's that?
I think that everybody can answer, but this is sorting and encoding.
Boom. Got it. So you get one. This is an extra large. There you go. Very welcome. All right, let me see what the next one is here. Okay, what degrades the performance of a Columnar Store database? What can drive it crazy? Okay, I got this guy over here. I tell you, you guys are just awesome. Come on up and get your prize. And then I got, there you go. Congratulations. And now for kind of my grand prize here. Yeah. This is called a Burgi. Every yacht club in the world has a Burgi, and it's flown on the mast of your sailboat. It identifies what club you're from. Okay? So if you go into our club, these are all, it's a tradition of yacht clubs. Anybody who visits brings a Burgi, and we hang them from the ceiling. So we've got like hundreds of these things. So anyway, this is here. And then on the back, it says Sausalito Cruising Club established 1948. Interesting thing about this club, it was started by a bunch of returning GIs after World War II. These are guys in their 20s. They had a really exciting life, and they wanted to party. So that barge I showed you, which is our clubhouse, the government was selling this stuff off for cheap. At the end of the war, they just said, we want to get rid of all this stuff. So they bought this, it was a munitions barge. They would haul ammunition in this thing, and they bought it for $250. And it's been our clubhouse ever since. And the wood that's used in this thing, you can't find wood like this anymore. It's big, thick, like redwood in the bottom of the heartwood, and it's used to support the whole thing. Those were the days. So this fine, lovely piece will go to the person who can answer this question. What is the difference between between historical data and a snapshot? Okay, wait. Didn't I already take care of you? Yeah, you can't have two.
Historical data contains all of the versions. Historical data contains all of the versions.
Yeah, it does.
Yes.
And what's a snapshot?
Snapshot's one of the latest.
Only the latest,
Yeah.
right. Okay, I mean, you didn't win one before, right? No? Okay. Come on up. There you go. Congratulations. Yeah, so that's basically my talk, and we've got 10 minutes left, and I will now take questions if you have them.
You said that you like Postgres as relation database, but as we can see, you use MySQL and he's been logged to transfer records to Vertica. Why?
You're asking why we use MySQL instead of Postgres?
Yes.
Yeah. Interesting story. We started out using Postgres. Okay? Fantastic database. The problem with Postgres is that it's always been a little weak on replication. Okay? It's much better now, but go back to like 2010, and MySQL was better at doing what we call master A/B replication. So we would run one master with a backup master, and when we needed to change the schema, we would turn one off, do the changes to it, have the other one promoted, and then reverse it when it was done. The guys who did this, we hired all these people from Flickr, and they kind of wrote the book on horizontal sharding. So they came in, it was their decision, so we moved to MySQL. If it had been up to me, we would have stuck it out with Postgres, because I think it's just a better database for me. Yeah.
Thank you.
Again, if you use Vertica, it really works well with Postgres, because the copy format, the SQL, it's all just the same. You got a question?
You show us your ETL jobs where MySQL servers and binlog servers. What exactly is the binlog service?
Yeah, so in MySQL, and this is true also of Postgres, anytime you do any type of database operation like a select or an update, a DDL statement, right? It's going to write that into a log file. And that's called the binary log. It's in a binary format. Okay, so it keeps that in there. And the reason it does that is because if you decide to roll something back, it needs to not be in the database yet. Okay, so it goes into the bin log. Same thing happens with
like write ahead log.
Pardon me?
Like write ahead log.
Yeah,
in the
exactly.
Postgres.
It's kind of the same thing. The format of the MySQL bin log is actually pretty good. The one in Postgres, even Oleg will tell you this, that it's a little cryptic, okay? But it's getting better. They've done a lot of work to make the Postgres bin log more readable by third-party software.
Thanks.
Okay. Yes, sir. This gentleman in the back here.
Thank you for the talk. I wanted to ask the daemon that reads the binary log and publishes the changes into Kafka. Is that something freely available or?
Not yet, but we're gonna. Etsy is very big on open sourcing stuff, and we're gonna open source that at some point. By the way, does anybody read a blog called Code as Craft? Anybody ever heard of that? Okay, good. Yeah, it's a really popular blog, and so we're going to do a blog entry on that, and we'll give this stuff away, open source it.
Thank you.
It should be probably 6 months, within 6 months. Anybody else for a question? I'm dying to have a question.
Hi, thanks for the talk. You mentioned that some of OLAP databases lacks primary keys. Maybe you have some recipe how to deduplicate data in.
Are you asking why? Is there a problem with not having primary keys?
No, I'm asking why. How we can deduplicate data? Because some message queues have not strong enough guarantees to just once delivery.
I'll answer that by saying that just because the analytic database, OLAP, doesn't really care about primary keys, your data is already validated because it's coming from a relational database where you do have primary keys. Let's say you had a student table, okay? And in Postgres, you have student IDs. By definition, it's already pre-checked out. There's no problem with it.
What if you insert a same event twice?
In Postgres, you're going to get a constraint violation.
But in something like Google BigQuery or Redshift?
Right. So you're asking so that actually can happen. But you're generally not doing inserts sitting at the terminal doing that. You're using ETL process to bring the stuff in, and most of your queries are reads. Okay? You may be writing to a different table, but you're never going to do an insert, update, delete to one of your core tables. I mean, it's just, you don't have to, right? You're bringing this stuff over from Postgres. The data is already constraint validated. It goes in there, and unless you've got somebody who's playing around, it's going to stay. It's going to have integrity.
Okay, thank you.
Anybody else? Yes, sir.
Thank you for your presentation. Am I right that in your main data table you store only the latest changes and the whole history of changes you store only in analytics databases?
That's one of the patterns.
Yeah.
So you can actually do the change history in your relational database if you want. It may slow down your queries a little bit.
Yeah.
Right?
Yes.
So that's why I said maybe the best thing is to just leave your, especially if you're using an ORM like Django, which is doing updates and deletes anyway, as long as you can do like a trigger or something to get cognizant of every change. I don't think you even have to do that. I mean, let's say I have record 1, 2, 3. Okay, and then there's an update 1, 2, 3. Well, you've already brought 1, 2, 3, the original one, over, right? And so the next one, you can just bring that over and it'll be probably fine.
And the whole history of changes, is it needed only for analytics?
Yeah.
So
there
you
are
don't have some cases when you need the historical data to restore something.
There is. That's why I gave that example of the address table, because you could show to your users, hey, here's all your addresses that you've had. That's a useful case. It may be also useful to show them, hey, here's all the changes that you've made to like the title of your jewelry. That's useful. But that's really a decision on the business processing. Do you want to do that? Does that make sense for your user to have that?
And in your business process, you don't need it, yes?
No, because you know when Etsy started, it was 2005. The analytic databases didn't even exist, and the young guys who started Etsy didn't know any better. So they just said, "Oh, well, update, delete. Okay, we lose some stuff. Big deal."
Okay, thank you.
Anybody else? Yeah.
Thank you for your presentation. I have just one question for you. Why do you need snapshot data in your analytic database?
Because the analysts often, every day, they want to know what happened yesterday. Did the sales go up? How much sales was yesterday? That's a snapshot question. Okay? But they also want to then analyze trends. So they want to go back over time to say, well, all of a sudden this item started selling. What happened to it? If you don't save the historical changes, then you can't answer that question.
Okay, you have historical data, and your snapshots, you store snapshots as some slices in time.
You could store every day. You could store a new snapshot, and you could have a history of snapshots if you wanted. But you're spending a lot of data there. You know, why not just do a daily snapshot? You've got the historical stuff. You can actually change that query where it says k equals 1 or the column number equals 1. You could say, well, give me the second one. So that would give the second layer of previous layer. It's just, I think it's more flexible this way.
Thank you.
Okay.
Question about performance. So when you show example, you start with high cardinality to low cardinality. And that everything works well on female and male. But for example, if query includes like category of sales plus cities plus geography, so you're moving down to low cardinality, and then what happens with the performance?
It's actually pretty good because it's all about. I'm going to go back to this thing here because I have a graph on this. Let's see. We're getting there. Okay. It's all about the path to the data. How quick is the path to get to the data? Okay. So here you can see that if we want to get, you know, here's what you're talking about. Okay, I've got this, but you know, what is it this to get the next level? Well, this already knows about this, so it's just 2 steps to get it. It's already kept in that storage container.
But you don't, basically, you're not interested about like gender. You're only interested about like cities.
Ah, okay. So.
Plus, for example, cities plus category of merchandise.
So the way they do this in Vertica is you create a different projection which has a different leading column that you sort on. Okay?
All right. So you need like basically different physical.
Depending on the.
You need, and that maps into larger storage.
Yeah. No. On Vertica it doesn't because Vertica only charges. Yeah, there's more storage space, but you're not paying for it. Vertica says, okay, you have the anchor table. And if you can create as many projections as you want, and they don't double they don't count that against your license.
Ah,
okay?
Well, but in physical storage, of course.
Sure, they do, but you know, storage is cheap.
Okay.
Right.
Okay.
So so that's the way you do it, and you would do it on BigQuery also. You would reorder how the data is.
Okay. Thank you.
Yeah. We're gonna get kicked out of here in a couple minutes, so.
How to deal with joins on high cardinality columns? Well, for example, say you have 2 tables from different data sources,
yeah.
one of, for example, Clickstream, or another, I don't know, something else, and you need to, well, identify patterns.
Right, here's the deal that if you're doing a join, it's going to want to do that in memory. Unless you can line up the data from the two tables so that when they're both reading, they're reading the same thing and they can merge on the fly and there's no need to put it in memory. It's called a merge join. You can all these databases have that, and you can read about that. Yeah, and even these databases, there's a thing called delta encoding. So even if you have primary key, it can actually do pretty good encoding on that because it says this is number 1, and then this is number 2, and then the next one is +3, and so forth. It's kind of a series. And so there's a pretty clever encoding and compression that happens. Yeah.
Chris, sorry, may I give a short announcement? Уважаемые слушатели, следующего доклада не будет по уважительным причинам, поэтому можем, в принципе, продолжить задавать вопросы. И извините за предоставленные неудобства.
Do we have to get out of here?
So you can answer another questions if you want to.
Okay, is there any last question, or are we all done here? I want to thank you all for coming and listening to my lecture. I also want to say that I think Moscow is a fantastic city. I actually did this talk 5 years ago, not the same talk, but a different topic. And I think Moscow is beautiful, and it's even better now than it was 5 years ago. Tomorrow I'm going up to St. Petersburg for a little bit of sightseeing tourism, and I hope I enjoy it. But thanks again very, very much.